In our last video, we saw a little introduction to exceptions and how we can use exception handling to do things like handle a case where we try to convert a string to a number, and the data in that string is not actually a number. In this recording, we're going to see how we can use exception handling to smartly toggle between an online and offline mode. So, this class here is the plant results activity. The plant results activity accepts a parameter, a search parameter, and what it will do is it will call this implementation, and that implementation will take our search string and pass it to a network DAO, and that network DAO will take a URI, okay, or just consider it a URL if you prefer. Query for some data from that URL, and then return that data. But the inherent risk here is that the network may be unavailable. And so the way we've chosen to handle that is with a try-catch block right here within our plant DAO impl. Plant DAO impl is a class that we've written before. And Plant DAO impl does this, basically facilitates this network call. But we have a similar class, let's remember. There's another class we wrote earlier called Plant DAO stub. Okay? And Plant DAO stub is just a little stub that returns some known data. Okay? So the Plant DAO stub might be a good way to fall back if we don't. Okay, oops. Looks like I might have deleted something here. Okay, there we go. Plant DAO stub might be a good fallback in case we have some kind of network issue. So let's see what we can do here. I'm going to go to Plant DAO impl. Okay, there we go. I'm going to go to Plant DAO impl. And remember, when we have a checked exception, there are two things we can do. Number one, decide that we can handle it locally. Number two, if we cannot handle it locally, send it up to the method that called us and have that method handle it. Okay. In the Plant DAO impl, if we get a network exception, there's not much we can do. So what I'm going to do is I'm going to remove this try-catch block. Okay. And because, okay, let me Control A, Control I to refocus my indents. What's interesting here is that because network DAO request URI returns or throws a checked exception, we have to handle it somehow. We either have to handle it locally with the try-catch, or we have to throw it back one more level to the method that's calling this method fetch plants. So two options. Number one, handle it locally with the try-catch. Number two, throw it back to the method that called us. To be honest, within Plant DAO impl, there's not a whole lot that we can do to handle this. So what I'm going to do is I'm going to go to this suggestion here, and I'm going to tell it to add a throws declaration. And I'm just going to say throws exception. What that does is that makes this method throw a checked exception, which means, okay, now the method that calls this must deal with this exception. So we're basically sending it up one level. Plant DAO impl is called from our plant results activity. So now we're saying if there's a network error, Plant DAO impl is not going to handle it. It's going to throw it back to the plant results activity. It's going to let plant results activity handle it. Plant results activity is going to have to decide what to do. Now I have to do a little bit of cleaning up here. Pardon me 1 second, Control 1, add exception to the interface. That's what I want to do. Okay, and save. I have to do a little bit of refactoring because I'm implementing an interface, but it should just be a few more moments and we should be in good shape. Let me go to Plant DAO stub, and is this going to be mad at me? Might have to make a little change here and save. Okay, I think we're good. We're good. Okay, just a bit of refactoring. Now take a look at plant results activity, and I'm going to Control M, and we see something interesting right now where we're calling down the Plant DAO impl. It's giving us a red line because it's telling us unhandled type exception. It's telling us fetch plants method now throws a checked exception, and we have to decide how to deal with it. plant DAO impl throws a checked exception on the fetch plants method, and we have to figure out how to deal with that. What do we mean throws a checked exception? Remember, I took away that try-catch block, and what I replaced it with is this line here that says throws exception. Throws exception. Okay, I've replaced it with this line on the method that says throws exception. The definition of a checked exception is the method signature contains a throws clause. The throws clause is followed by an exception type, many times just exception, and that means if you call this method may throw a checked exception, and you're going to have to figure out how to deal with it. Okay. Luckily, we have a very easy way out here. We have a very easy way out. Okay. If we can't get to the network, we can always fail over, and instead of using plant DAO impl, we can use that stub class that we created before, the plant DAO stub. And the plant DAO stub doesn't rely on the network, it just gives us back some hard-coded results. But you know what? That's an easy out if we don't have network connectivity. Maybe at some future date we can change that to hit a local source of data instead of requiring the network. So what I'm going to do now, I'm going to refactor a little bit. I'm going to take this return, I'm going to control 1 here, assign to new local variable. Okay, there we go. Return fetch plants. I'm just breaking this line into 2 different lines. Now what I'm going to do, I'm going to do a little bit more refactoring. Fetch plants equals, like so. So I'm taking this line that was 1 line, breaking it into 3 lines. Okay, move my comments around a little bit so they match up again. Okay. Declare our return variable. Okay. Pass our search parameter to the fetch plants method. It will return a populated array list of plant objects. Okay. And now return a populated list of plant objects. Okay. So, this is the method that could have the risk. Okay, this is the method that's throwing the checked exception. So I'm going to say surround with try-catch. Okay? Now remember, if there is an exception, what's going to happen is it's going to go down to the catch block. If there is no exception, it will skip the catch block and continue executing after that. Now what's neat is that my easy out here is I can just make a plant DAO stub object, plant DAO stub equals new plant DAO stub in this catch block. Okay, plant DAO stub dot fetch plants, and we'll pass in that search parameter. Okay, whoops, sorry, went off a little bit there. Fetch plants equals, boom. Okay, Control Shift O, organize imports, and let me put some comments here that will explain what I just did. This catch block will only execute if the line in the try above fails and throws an exception. The line above will throw an exception only if the network is unavailable. Plant DAO stub relies on hard-coded data and does not require the network. Okay, network. Okay. Ask plant DAO stub for a list of matching plants. So this is a good either-or situation. In the try block, we're going to assume that we have network connectivity. If we don't, we're going to fail over and use a local copy of data that we get within this stub class. Either way, at the very end, we're going to end up with a collection of plant objects. So this is a way we can do a very nice online-offline toggle that's completely seamless to the user. completely invisible to the user. When we're online, we use live data. When we're offline, we just switch over and use a local copy of data. This is a very common design strategy in mobile development. And it's something that you should really consider if you are using a live data source. What you don't want to have happen, you don't want the application to crash if the user simply happens to lose network connectivity for a period. That's a very significant consideration in mobile. What does happen if the user loses network connectivity? Because it's bound to happen, honestly, quite frequently. And we don't want that to throw an exception that will terminate our program. The problem is this: if we do not catch an exception and that exception gets thrown, it will crash our program. And if it crashes our program, our quality suffers, and that will probably show itself in our store ratings. So that's obviously a situation we don't want. So I'm going to go ahead and debug the program again. And what we're going to see that's different is honestly nothing. And that's the whole idea. We're going to see that the program continues to run regardless of if we're connected to the network or not. A good test for this would be to physically disconnect the laptop from the network and watch what happens. And what you'll see is that it just fails over and it goes to our stub. I don't think I'm in a good position to disconnect the network now because I have another video uploading and I don't want to interrupt that process. But that's a good way to test it. As a matter of fact, if you go to the Android quality guidelines, one of the things it's going to say, well, it's going to give you a list of things that you need to check in your application before you release your application live. Things like switching from portrait to landscape mode quickly. Does your application handle that? Other common user interaction things. One of them is, let's see if I can. Okay. Okay. CR0. Navigate to all parts of the app, all screens, dialog setting, and user flows. If the application allows for editing, content creation, gameplay, or media playback, make sure to enter those flows to create or modify content. When exercising the app, introduce transient changes in network connectivity, battery function, GPS or location availability, system load, and so on. So before you release an app to the Play Store, you have to test the app by turning the network on and off and making sure that the app responds without crashing. The best way to do this is to use, let me go to search plans. The best way to do this is to use the try-catch mechanism that I've just shown you. So we'll go to search plants, and again, we're not expecting any differences here. We're expecting it to work as it always has. What's better now is that it is more resilient, and that if we drop the network for some reason, if we are to lose network connectivity, it will continue to work for us. So we see here that without network connectivity, it's just giving us the Asimina triloba and the lavender twist red bud that we're used to, because something failed on the network layer. So what it did is it just failed over and it used the local stub instead. So that's what we see here. A well-designed program will know how to handle exceptions, and when it catches an exception, it will be able to either handle it locally and fix the situation locally, which is the preferred approach. If we can ever fix locally, that's what we want to do. On the other hand, if it cannot fix it locally, then what it will do is it will throw the exception back up to the layer that called it. In absolute worst case, if we can't handle the exception, let's notify the user that we can't, and maybe offer the user some alternative workaround, or just tell the user that, hey, network's down right now, I can't survive without a network, something like that. Let's notify the user what might be going wrong. So, exceptions, great idea if you are using the network. And that's all I have. So we took a look at throwing exceptions, we took a look at catching exceptions, and we took a look at online offline toggle. Thank you.